students. I am Samir Velankar and I welcome all of you to this GATEvantage Series lecture which is organized by the GATE Academy, and today we are going to cover DBMS topic, Database Management System, and the name of the topic is ER model, Entity Relationship Model. Although the topic I am going to cover is ER model, very early I will tell you that ER model can't be seen alone. It has to be associated with another topic called relational model. So I am going to mix both topics. It's obvious that anybody learning ER model will quickly run into the other topic called relational model. So wait, we are going to jump into relational model after some time. But before that, let's explore what do you mean by ER model in database management system. To understand this, let's have an analogy. Let's assume that, let's say that we are building a house, maybe villa, mansion or bungalow. But then we are really very new to what you say civil engineering techniques, and we only know what should be the nature of our house. I mean, where should be our parking lot? Should we have a garden? Or where should be, in which direction the kitchen should be, and so on. So we are very thinking at a very superficial level about our house. So what we do is, obviously we call expert, maybe an architect, and we explain our requirements to that architect. And architect comes with a model like this, keeps on the table, maybe build of plaster of Paris, and we are happy seeing this model, and maybe we suggest a few changes, and the engineer will come back with the revised model. Unless we are happy, with the model, a step ahead cannot be taken. So this is the first step. Obviously, the requirement of a customer. I am the customer, and obviously the civil engineer or architect should listen to the requirements, take down the requirements, and properly reproduce those requirements in some pictorial form. Check my words, pictorial form, because that is the only language that we understand. We don't understand the technology behind civil engineering. Now, what happens next is that civil engineer then prepares a plan. This plan is hardly understood by us, but we have a full faith on the architect, and we know that this is actually modeling our requirements. Of course, we know a few things because some few things are labeled here and there, and some feet and inches and some dimensions have been modeled, but we are not engineers in that particular field, so we don't know what this plan is. But definitely this plan has been made keeping our requirements in mind. Now, the third thing, once this model gets certified, maybe from civic bodies and the municipalities and so on, and the last thing that the architect does is actually orders cements, bricks, steel, and actually starts constructing the home. Now, you see these three steps. Basically, why I went through these steps, is because this is how an organization who is not using database management system or computerized system, and maybe an organization is still working on paper. Strange, but they are still working on paper, and they want that this data should be computerized. That means the data which is on the paper should be now transferred to computer. And not only that, we just don't want to store the data in the computer, we also want to intelligently retrieve the data. What? Retrieve, get back the data. That's known as query. We want to know what's stored inside. So if these are the requirements, now let's switch over to our subject, database management system. If these are the requirements, I run an organization, but I still maintain the data on paper, and my requirement is I want that my data should be stored on computer. So obviously what I do is I call an expert, obviously the database management expert, and you can now map the facts that I told you just a few seconds back. The requirement was building a bungalow. Here the requirement is computerizing the data. But I am ignorant about that. I run an organization, I am very good at it, I am very good at management, but I don't have ABC skills of programming or database management system. So what I do is I call an expert and I give my requirements, just as the bungalow owner gave his or her requirement. These requirements are modeled by the expert in the form of pictures, the diagram, which can be very well understood by a amateur, by a person who doesn't know anything about DBMS. But these pictures speak enough. So this is a ER model. Exactly, this is a ER model, which coincides with the model kept on the table made of plaster of Paris. This is a great way of communicating with our customer that what kind of data do you use in day-to-day life on the paper, and what relationship that data has with each other. By the way, many beginners, feel that, oh my God, this ER model looks so complex, so complicated. This numbers, 1, n, squares, rhombuses, drawn and all that. I promise that within half an hour, you will be clarified with all these details without any pains, This is very interesting. By the way, what is ER model in that case? It is a conceptual idea given to the customer who wants to actually computerize the data. But how is this model drawn? Obviously, you will have to talk to customer. You will have to note down the requirements properly in your own favorite language, maybe English. Make the sentences, read out the sentences, take the requirements, and then finally come up with this diagram. What happens next? Once this diagram is certified by the customer, like this model was certified by bungalow owner, the next step is engineer prepares the plan, I told you. So what happens in DBMS? In DBMS, we have something called relational model. You see this, that whatever pictures were drawn in the form of rectangles and rhombuses and all that got converted into something called tables. But this is not it. See, this is still on paper. This particular plan is still on paper. This relational model is also still on paper. It is on paper, waiting to get certified, waiting to get tested. Numerous tests are held on this, which in DBMS we do. But by the way, now finally, the third model comes into picture, physical model. First was ER model, second was relational model, and third is physical model. Physical model is where the architect actually orders cements, bricks, steel and starts building. Here in DBMS, once the relational model is certified, once we know that it is correct, we start actually storing the data on physical device such as hard disk. Nicely, the analogy fits really. And see, actually DBMS is 3 level. If you want to learn DBMS, you have to learn 3 levels. That's it. So ER model, relational model, and obviously physical model. We are going to talk about ER model today. So best of luck everyone. Let's go through a very interesting session, and I would like that you keep this session very interactive. Talk to me. You can ask your questions on the chat. I will readily answer it, and we can have an interesting and interactive session today. So, by the way, let's go back. Let's go to our topic, that is ER model. Let's see definition of ER model first of all. Entity relationship model. It is a conceptual idea given. As I said, it is used to define data elements and relationships. I mean, when you talk to the customer, you ask customer that, okay, you are maintaining the data on the paper, but whose data are you maintaining? So customer can come up with answers that we have lot of consumers. Okay, that means you maintain data for consumers. To whom we sell lot of products. Okay, that means you sell products, so there is data for products. So that's what you call by data elements. That means you want to store data about what is actually learned in ER model. And you see, it develops just a conceptual design idea about data. that we are going to store. So you can say that this is just a teething happening to a small child, where we are supposed to go a very long way. So ER model is just a stepping stone. So by the way, by the end of today's class, I'll be glad if you understand two words: entity, relationship. You have to clearly understand what relationship between the entities are we talking about. So first of all, as I said, you have to understand two words: entity and relationship. Let's understand what we mean by entity. If the easiest thing, if I say what is an entity, every cricket player is an entity. Okay, take another example. I mean, every teacher is an entity. Fine. Okay, take another example. Every object in this real world is an entity. So, is this pen a marker, an entity? Yes, definitely it is an entity. Or is this board, magnetic board, is this an entity? Definitely. So any object is an entity, person is an entity, or a place is an entity. Like library is an entity. Now why are we calling these entities? You can loosely take that if it is a noun, N-O-U-N, noun, then it is an entity. You can call that as an entity. For example, employee works in department. Let's say we say this sentence: employee works in department. Then employee is an entity, because employee is a person, correct? So employee is an entity. Works in a department. Now department is an entity because department is a place. It's a noun. So basically, if you want to define what is entity, what is an entity? An entity may be an object, person, or a place. Any noun is an entity. For example, employee is an entity, or maybe department is an entity. Now I told you that we are going to draw diagrams here or pictures to explain our customer about what's the data going to look like. Then every entity is always drawn in rectangle, and we just write the name of the entity over there. For example, if the customer says that there are many employees in my organization, okay, you catch employee is an entity, and then you mark it like this in a rectangle and you write that entity name over there. By the way, every entity has attributes. Yeah, you see, entity cannot exist without attributes. At least I have not seen. I mean, if I ask you that you know that this marker is an entity, right? It's an object, so it's an entity. You will say yes, definitely it is an entity. And then if I ask you that do you know attributes of this marker? You may think a bit, but you may say thickness of marker is one of the attributes. Okay, and then you just don't click. Hello Krishna. You may say thickness is an entity, thickness of the marker, or you may say cost. That's the simplest thing you can say, cost. Come on, every marker must have cost. So everything in this real world, if it is an object, if it is a place, it will definitely have attributes. What attributes talk about? You see, let's say an attribute is used to describe a property of the entity. Like when I said cost is a property of this marker, or thickness is a property of this marker. So when you think of an entity, you always think about its attributes. Let's say that student is an entity. Let's take very simple examples here. Student is an entity. Now think as a student in a college or in a school. What will a student have? What properties the student will have? Student will have a unique ID. We call it as roll number. Student will have name, come on, obviously. Student will have address and many more things. Guardian name or parent name. Then student will have phone number and many more things. So these are called attributes of student entity. Now all the attributes are shown in oval. the entity itself is shown in rectangle, and we just show the lines or edges, and in the oval we write the entities. So I have shown only 4 entities here. I mean, in realistic examples, when you talk to the customer, I mean, they may say that every student has address. I have not shown address over here. So it depends on the requirement or what kind of data about the student you want to store. So what are the 2 things? Is the first thing is entity. Second, every entity has attributes. Entity is shown in rectangle. Attributes are shown in oval. Now you see, there are many types of entities. Wait. There are many types of entities, and there are many types of attributes. What did I say? 2 words we have known, entity and attribute. There are many types of entities and there are many types of attributes. Let's first of all talk about types of attributes. Okay, in this diagram itself we will see the types of attributes. You see, just imagine student has phone number. You can read it like this: student has ID, student has name. So these are the attributes. Student has phone number. It may happen that a student has multiple phones. That's quite obvious that 2 phone numbers or 3 phone numbers student has. In that case, phone number we say may be, check my words, phone number may be multi-valued attribute. No, every student need not always have multiple phone numbers. We are saying that if there are many students, then some student may have multiple phone numbers. So there are chances that this phone number given to a student or student possesses a phone number, this can be multi-valued. There can be many phone numbers for a particular student. So what we do in that case, you know, in our ER model, we show this as a double oval. Whenever you see a double oval and inside that we have written the attribute, then it means that this is a multi-valued attribute. It may happen, just check this, it may happen that student has, this may happen. Definitely student will have address. So this is one more attribute, but it may happen that student has multiple addresses maybe. One is the permanent address, one is the care of address, and another alternate address the student has. In that case, you can show that address is also multi-valued. It may be multi-valued, you are saying. And generally, we store only one correspondence address, but it may happen. But common multi-valued attribute is phone. Student may have multiple phones. So this is a multi-valued attribute. Coming to name. Just check. Actually, you know, you may say, okay, name is a proper attribute. I mean, you just don't have to talk about it. But when you think of name, you know, name actually contains 3 parts: first name, middle name, and last name. What if you say that student has name and name is made up of first name, middle name, and last name? So I have made 3 more attributes, F name, M name, L name, to suggest that student has name and name itself is made up of 3 parts. Such attribute is called composite attribute. This is multi-valued attribute. This is composite attribute. So don't make any rules. Hello, boys and girls, don't make any rules. You may say, okay, from now onwards, whenever there will be a name in our ER model, we will show it as composite. No. Suppose you are talking to your customer and customer says that our consumers, we store names of our consumers. We want to store names. You ask them, do you give importance to first name, middle name, last name, or you store the name just like that? Consumer may say, no, we store the name as such. That's it. We don't want to separate them and keep F name, M name and L name. Fine then why do you have to show composite attribute? See, all these things, will be learned only when you talk to your customer. I mean, how finely granularity you want in your data. So, but by the way, I have shown name as composite attribute. Maybe you may think of address. Address is a very good example of composite attribute, because for address, we may say address is made up of street number, city, building name, and so on. So address also may be, check my words, may be composite. If your customer says, no, we store address just in one line like that, we don't have to segregate what is the block number, street number, then you don't make address as composite. So what are the two types of attributes? Multi-valued, composite. Now the third type of attribute is very interesting. It is called as key attribute. It's called as key attribute. And usually key attributes in the ER model or ER diagram are shown underlined. I purposely left it to be drawn now, but ID is what student has, and we say every student has a student ID or roll number. Now why do you call this as key attribute? This is a remarkable way by which you can identify the student in a big institute. Names are not enough. I mean, let's say a visitor visits my institute. I am studying there. I am studying in an institute, and visitor, my friend, visits my institute and meets the receptionist and says, I want to meet Samir Velankar. Receptionist will search Samir Velankar and would say, surprisingly, there are 4 Samir Velankars. Which Samir Velankar you want? So look, it's very difficult. I mean, then that person will say that Samir Velankar who stays in Kormangla. So the receptionist will search the data and would say that there are 2 Samir Velankars out of those 4 which stay in Kormangla. Which Samir Velankar you want? So even addresses can repeat, I mean, isn't it? The town in which the person stays may be same. So what is the unique way of identifying a student from other student? We give number. That's why roll numbers are given, and roll numbers are unique for every student. That's not enough. Roll numbers are unique for every student, and roll number cannot be empty. I mean, let's say I am a student and I go and shout, I do not have roll number. That's impossible. Student must have roll number. We call this as not null, N-U-L-L, property of DBMS. ID field, student ID field should be unique for every student. ID must be unique, and it cannot be null. There cannot exist a student without a student ID. We call such attributes as key attribute. One very fantastic thing, about this, our engineering field, especially about our engineering field, is whenever any term, any phrase, any definition, any topic is named, they think properly and name it. See what they have named this attribute as? Key attribute. What's that key? We know key is generally used to open the lock. Are we talking about that key? Yes, that's the key we are talking about. Come on. Now, the stranger visits my institute, wants to meet Samir Velankar. It is full lock. We don't know where Samir Velankar is, but that person has a key. What if the stranger knows that I want to meet Samir Velankar who has ID 1234? Receptionist will quickly spot that unique person in the entire institute. But for that, the stranger must have the key. If the key is there, spotting out a person will become so easy, magnificently simple, isn't it? That's why that word key appears over here. By the way, 3 types of attributes we saw. I hope you are enjoying till now. See, this topic, is so so interesting to be learned with these real life examples, that certainly, after a period of time, it really actually it dissolves very nicely. So by the way, 3 types of attributes we saw: key attribute, composite attribute, and multi-valued attribute. Last type of attribute is not so interesting. Why I'm saying not so interesting is because it is known as derived attribute. Just check, age is one of the attributes which is derived actually. Why? Because when we store data of student, come on, we will definitely store date of birth. At least I have not seen any institute who maintains data of students on paper without storing date of birth. Now, we have stored date of birth of a student. So, student has date of birth. This is an attribute. Then what's the point in saying that student has age? You see, age is continuously changing, isn't it? At the moment also, my age is changing by a fraction of a second. But then if I tell you my date of birth, you will instantly calculate my age. So what's the sense in storing age of a person? But by the way, if this is done, then this is shown as dashed oval. Dashed oval. Whenever you see dashed oval, you will say, okay, that means there is some attribute over here, some attribute surely, using which you can calculate this. So why I said, this is not so important, because many times what happens when we talk to our customer who wants to computerize the data, then we take all the requirements, and whatever he or she speaks, we actually note it down in the form of diagrams. We don't bother at that time that what's which type of attribute. And then when we sit and study, we know, okay, this can be calculated using date of birth. If we are going to store date of birth, why are we going to store the age? So ultimately, at the end of the day, when we reach the last step, this age won't be there. This particular attribute will not be stored, but date of birth will be stored. So why I said this is not so important, because anyway we are going to ignore such attributes which are dashed ovals. So 4 types of attributes are there: composite, multi-valued, key attributes, and derived attributes. Now, once we saw how many types of attributes are there and so on, now I hope you know what is an entity. Definitely, like student or maybe employee, any such object or place or a thing is an entity, and every entity has attributes. For instance, if I ask you, think of employee entity, okay? You are thinking about an employee. What will employee have? Employee will have ID again. Every employee, come on, is always given an ID. I also have an ID at GATE Academy. Employee will have name, salary, obviously that's what that person is working for, address, marital status, and number of children, and so on. Many more attributes will be there. Phone number might be multi-valued. So this is how entities are. And note, the most central point of DBMS is entity. We have data because we have entities. If there were no entities in the real world, we won't have data at all. So after knowing entity, let's come to the next point. Okay. Relationship. I said you just have to learn 2 words with me: entity and relationship. We are up to the second word now, relationship. What if I say that in a real DBMS, database management system, an entity cannot stay alone. It has to be related with some other entity. No, I will correct myself. I was partly correct actually. Not only in DBMS, in real world also, an entity cannot be alone, has to be related with something. I am an employee of GATE Academy, then I am not alone. I am related to all the operations which are happening in the GATE Academy. So when we think of data, when we think of entities, they are related to each other. Best way to understand and exemplify the relationship is to see an example. But you just watch the example first. I will draw some pictures over here and you can ask some difficulties or some queries that you have on this particular statement. Just check this statement. There are many employees working in an organization. Just check, there are many employees working in an organization. Every employee must work in exactly one department. So if I am an employee, I should work only in one department. That's very nice organization, because mostly, you know, in an organization, an employee is asked to work in more than one department. And a department can contain 0 or more employees. From where did we get this English statement? We got this English statement from our customer, who is interested in actually storing data of employees and departments in a computerized way. So we come up with the ER model for this sentence. Now look, in this sentence, you know, employee and department are nouns. Employee is a person and department is a place. So they are nouns. So ultimately, what we do in our ER model is we make employee as an entity, rectangle, and we make department as another entity, rectangle. So there are two entities in this. Now somebody over there might say, sir, organization also seems to be a place. If you are saying department is a place, organization is also a place. So why are you not making an entity for organization? Now look, my dear friend, we are writing this particular database scheme for the organization, correct? And if we again make an organization entity, then all these things are part of the organization, isn't it? I hope you understand. So we won't go to that superficial level, but we say that there are two entities, employee and department. Now just don't think of relationship till now, but what a typical employee has. Employee may have employee ID. Let's name it as EID. Some name we have given to the attribute, and this should be key attribute. Agreed, everyone? Because every employee will have unique ID. Every employee will have name. Let's write it as ename. And every employee will have address. And employee will have salary, obviously. And so on, phone number and so on. I'm not showing all the attributes, but imagine these are the attributes of the employee. Now what the sentence suggests is that our company has departments in which employees work. So let's not think of relationship till now. The topic is relationship, but let's not think about it, but think about a department. Think about it, department. What a department can have. Department also has department ID. Yeah, surely, if there are 10 departments in an organization, then every department is having department number, so that we can uniquely identify that department. Let's name it as DID, department ID. So this should be unique for each department and it cannot be null. This is the key attribute. Now every department will have name. Let's name it as DName. And every department will have address. Maybe some department is placed in one part of the town and other department is placed in another part of the same town. Then we would like to store department location. Let's call it as DLOC. Now we have spoken about both the entities, but look at the sentence. Can we leave these two entities? Now enjoy yourselves, enjoy your time. No, you see, clearly the statement says that there are many employees working in an organization every employee must work in exactly one department. So there is some relation between employee and department. Now, how do you identify relation? Actually, relationships are nothing but verbs. V-E-R-B, verbs. Verb is nothing but an action. For example, employee must work. Must work. This is a relationship. We know now that, okay, employee actually, works for department. See the relationship between the two entities. And the relationship is always shown in the form of rhombus. Nothing extraordinary about it. You will say, why rhombus, sir? Why not circle? Why not ellipse? I don't mind. But the people follow this convention so that it's a global convention. Everybody understands these symbols globally. That's why we carry the same notations. And what is the relation? We write here description of the relation. So anybody reading this would easily say that employee works for department. This is the relationship between the two entities. By the way, n number of examples can be given about the relationship. But just one more example let's take. But before that, what is a relationship? Relationship is used to describe the relation between entities. Wow, what a definition. What else it can be? And diamond or rhombus is used to represent the relationships. The role, of the relationship, the description is so important. I mean, because if you don't write the description in crisp words or minimum words, then the very intention of showing relation will be lost. What if I would have shown department on this side and employee on this side? Would it make some difference? I mean, if this was, I'm not erasing, just asking, department and this was employee, obviously we will say department employs, or hires employees. But then still works for doesn't change. I mean, you very well understand that means employees work for department and departments hire the employees. So it doesn't matter where you show these entities, some entity to left or right, and then you may flip, make a mirror image of that. But if you make mirror image, just make sure that you write role properly. Okay, let's take one more example here. Do we have another example? Let me check. Okay, here we go. Let's say, just ignore this right now. One-to-many relationship we are talking about. Every student can borrow one or more books from library. Just check the sentence. Student is a noun. Okay, book is a noun. Even library is a noun because it is a place. But if we are writing a DBMS system for library, then library cannot be thought of as an entity because library contains books, something like that. So just don't go to that level to say that to say that library should be an entity. Thanks, Devrat. Very nicely explained, sir. Okay. I am very happy. I am very glad that you are understanding the facts told in up to this point. Now, you very quickly catch that student must be an entity, correct? And book should be an entity. And what do you have? Student borrow. Just check. It's a verb. It's an action. Student borrows a book. So definitely the relation between student and book should be student borrows book. Let's check. Of course, student will have attributes like we will say SID, student ID. Every student has got some roll number. Let's call it as student ID, student name, and so on. I'm not spending time in showing attributes. It depends. You may store address of a student, phone number of a student. And every book has book ID. Of course, librarian will number each books, isn't it? a unique number will be given to each book, and we will have book name and cost of book and lot of things. But what we are learning is that an entity cannot stay alone. Come on, nobody can stay in this real world. I mean, basically whenever you think of an entity, there is a relationship of that entity with some other entity. Otherwise, it's of no use. It's of no use. I mean, then why would you create an entity if it is not related to any other entity? So, the role again is very important, how you read it, because role explains very well what's happening between the two entities. Okay, now once we have known, I hope you have known, Devrat has already told that he has understood whatever has been explained till now, and other students also can participate. But once we have known what is this entity and what is relation, next very interesting fact I am going to tell you is what are the types of relationships. Wait a minute, I promised you very early that there are many types of attributes. I kept my promise. I taught there are 4 types of attributes. But then I also said there are types of entities also. I have not kept that promise. I have not yet taught types of entities. I am saying types of these entities, like this one. There are many types, or rather not many, but few types of entities. I am still postponing that particular point, but I want to talk about types of relationships. Just check this. There are 3 types of relationships: one to many, many to many, and one to one. Come again, one to many to many, and one to one. You would say, what about many to one? Okay, take it, 4th one, many to one. Okay, but we are going to explore the 3 types. I'll tell you the reason why I am not exploring the 4th type. Okay, so what do you say now? Let's check types of relationships. The interesting discussion starts now. Just check this discussion. Okay, read out the sentence again about the relationship, this diagram. Read it out. Every student can borrow 1 or more books from library. Very good library. At least I have not seen such a library which allows student to take 10 books also. 1 to any number of books you can take. A student can borrow 1 or more books at a time from the library. Second point is, a book can be issued to exactly 1 student at any time. Obviously, if the librarian is giving book to someone, then that book will be handed to only 1 student at a time. That means book can be only with 1 student at any point of time. Of course, when the student returns the book, that student will be given to some other book. Isn't it? Yeah, exactly, Devrat. Many to one and one to many looks like same, sir. Yeah, definitely. That's why. That was my point. Devrat added it to that. Actually, you know, if you just flip them, the direction of the entities, then one to many becomes many to one, and so on. So is not much difference. They look quite similar. So, good point you added. So, by the way, a book can be issued to exactly 1 student at any time. Of course, a book can be given only to 1 student at any time, but that student can take any number of books. Please try to understand. So, there comes something called cardinality. Check my words. Cardinality of relationship. And cardinality is read as one to many to many. That's what cardinality means. What we now say, look, it is so easy. Just follow my rules. It will become so easy. You will never have to think about it. You know, I'll tell you, wait, before I explain, I'll tell you. A number of students, you know, watch this something like written n here, 1 here, and so on top of the lines. And then keep wondering, what is this n? Why it is not written that side and 1 is not written this side, and so on. A lot of puzzles here. But just check, you will have no question whatsoever after listening this. Here we go. You want to know what is the cardinality of the relationship. Okay, here we go. Let us say that there are many students. Look at our discussion. There are many students. Let's say S1, S2, S3, S4. Many students are there. So this student entity represents lot of students, isn't it? Now you ask this person S1, hello, how many books have you borrowed? You ask the student, how many books have you borrowed? This student might say, I have borrowed a book called B1. There is a book B1. But the same student might say that I have borrowed book B2 also. Oh, look at the problem. Please look at the problem. A student can borrow one or more books. So it might happen that this S1 says that I have borrowed B1, I have borrowed B2. And maybe this S4 says I have borrowed B3 book and I have borrowed B4 book and I have borrowed B5 book. All these are our books in the library. What you see, just check what you see here exactly, is that one student if you take, it may lead, one student may lead to many books. Which is the many side? Please try to understand which is the many side. Many side is the book side. Because one student may take many books. That means you have to write N over here. It's so easy. Actually, it's coming from the sentence. And you actually, interrogate a student, like you are speaking to a student. That you ask, student, how many books you have? Student will say, I have 10 books. So that student will be related to 10 different books here. That means this side is many, isn't it? One student can borrow many books. So N should come on book side. Now let's ask books. Okay. It's very difficult to ask books, but let's assume we are asking a book. Let's ask B1. This book, B1, you have been issued to which student? This B1 will say, I have been issued to S1, S1 and only S1. B1, the book won't say I am with S1, S2, S3, 3 students. It is not possible. Librarian won't issue the book to more than one student. That means if you ask any book here, this book will take you exactly to one student. This B2 will also take you to exactly one student. That means one should be written on student side. Look at it again from this side. A student can take N books, many books. A book can be issued to only one student. So simple, so simple. And we did nothing. Actually, we repeatedly, we spoke the sentence again and again and again and try to understand. Maybe you can convert the sentence in your favorite language. Who cares? But ultimately, you should know where you should write N and where you should write 1. That's it. Lot of confusions occur over here. I'll tell you that where to write N and where to write 1 is really many times, confusing. Okay, I'll just clean this because the things were not visible quite well. But then what we were learning about, student borrows, I could have written it below here, borrows books, book. For making our discussion easier, I am not showing attributes, okay, for now. Student ID, name and all that I am not showing. So how did you read it? Tell me again, how did you read it? Just speak with me. Any student can take N books, many books. N books, check my words, that means N should appear, many should appear at book side. Ask book. Some book you ask, you have been issued to which student? Only one student at a time. A book can lie only with one student. So 1 will be on the student side. Finished, period, that's it. Now, see, the things have become bit confusing, over the years, because many authors have used many notations for these cardinalities. Well, this is my favorite one, writing clearly 1 and n. But many authors have opted their own methods. So the another way of showing the same thing I am drawing 1 here, n here, I am not changing the numbers. Another way of showing the same thing is something like this. What many authors do, whatever is one side, they draw an arrow towards the entity. And whatever is n side, they don't draw any arrow. And they don't write any numbers. Now, what do you understand from this? There is an edge from borrows relation. This is a relationship to books, but there is no arrow. That means this is many side. There is a line connecting borrows and student, but there is an arrow towards student. That means student is one side. The same thing could have been written by writing 1 and n over here. And most of the times, questions asked in GATE uses this convention, arrow convention. They don't use the numbers 1, n, but we started with that because that's my favorite way of showing the things. So, shall we see one more example? Okay, not this one. Yeah, this one. Think of this. Just check the statement. By the way, the type of relation we are still learning is one-to-many. Anything you want to ask till now, or maybe after this exercise, you can participate. You can add a few more points to what I have said, or maybe you can ask your queries here. Listen, we are coming to a very big quiz, slowly and steadily. But you see that this is the requirement given by our customer. The requirement is there are many employees working in an organization. So definitely employee is an entity. Every employee must work in exactly one department. What did you get over here? Employee is an entity and department is an entity, and works is a relationship. So, by the way, we may say that employee is an entity and department is another entity, and they are related in such a way that employee works for department. This is the relation which we saw a few minutes back. And of course, we are not spending time in showing attributes like employee ID, name and all that. You better understand that if there is an entity, there will be some attributes, okay? But then what is most important is what should be the cardinality. Think over it. I mean, my question on the chat is that, okay, I'll disclose the answer partly. It is one-to-many. I have written that topic. So one should be written on which side? Employee side or department side? I want your answer as employee or department, whatever is your answer, but one should be written on which side? Employee side or department side is my question. One should be written on employee side or it should be written on department side. Where should it be written? Where should it be written? Definitely it is one-to-many relation. Waiting for your answer. Devrat is asking something. Sir, with the same book name, same author, same edition, book ID is different, sir. Definitely. Book ID will be different. book numbers are uniquely given by librarians. Okay, if you didn't like book ID, but every book will have ISBN number, that's unique. So a publisher may publish many books of the same author, same subject, but then definitely a book will have different ISBN number. So there has to be some type of ID which will be differing between the books. Okay, so I changed the slide, I think. Yeah. So what should be one side and many side? Here we go. Let's ask employee. Let's ask some employee that you work in which department? Now check the requirement. Every employee must work in exactly one department. So the employee will say that I work in one department, single department. There cannot be an employee who will say I work in accounts and I work in payment section also. It can't happen. You will say, why, sir? That are company rules. Company has, our customer has given these rules, our customer has given these requirements, and then if they have given us the requirement, definitely if you ask, actually if you go in the organization and ask an employee in which department or how many departments you work for, person will say only one department, sir. I work in, say, account section, or I work, say, in HR section. So an employee works for only one department. Please try to understand. One should come at the department side. What about department? If you ask some department, it's very difficult to ask a department, but imagine you ask accounts department. How many people are working? Accounts department will say E1 is working, E2 is working, E3 is working, E4 is working. 100 employees are working in accounts department. You ask a particular department, that the statement says a department can contain 0 or more employees. You may argue 0 or more employees. How can a department have 0 employees? If there are 0 employees, then why is that department there? Maybe it is a new department. Company has just now started it. Or maybe that department is about to get closed. So all the employees have been shifted to some other departments. But 0 or more employees. What do you understand is that a department can have n number of employees. Whenever you read this n, it is from the perspective of the other person. A department can have many employees. Employee can work only in one department. So what do you say? Which type of relation is this? Wait a minute. You'll say, this is many, this is one. Oh, this is many to one. Like that you will say. Because we are used to reading from left to right always. So you will say, this is many side, this is one side. So this is many to one. What if I flip this? Is the show going to change? Is anything going to change conceptually? No. So if you look at from that side, it is one to many. From this side, many to one. It doesn't make any difference as long as you write these numbers properly. These numbers have to be written properly. And what was the other way that I said? What was the another method in which you can show this? Is that instead of showing these numbers, you know that department is one side. So you show an arrow here. And employee is inside, so don't show any arrow. Just show the edge. That's it. So this is one side, this is many side. This is one to many relation. Any questions? I hope you understood one type of relation, one to many. Okay. So now let's go to the another type of relation. The another type of relation is called many to many. This is very easy. Obviously, from the sentence you will understand. Look, I have modified the sentence a bit. The sentence is that there are many employees working in an organization, again, and every employee must work in one or more departments. There is no compulsion, but there might be a very efficient employee who works in 7 departments. There might be an employee who works only in one department, but employee can work in multiple departments. In the previous problem, every employee should work only in one department. Here, many departments is possible. And a department can contain 0 or more employees. So how do you look at this? We have employee entity and we have department entity. Okay. And we know that employee works for department. Let's ask an employee. Some employee, let's pick some employee in the company, ask, which departments you work for? This employee will say, I work only for one department. Wait. Don't come to a conclusion, okay, that means this should be one. Hello, ask some other person also, how many departments you work for? That person might say, I work for 3 departments. Because that's the way how our organization is appointing people in the departments. What that means is, there can be some employees who work for multiple departments. This is inside. Ask a department now. Accounts department, how many people are working? How many employees? This department accounts may say E1 is working, E2 is working, E3 is working, E4 is working, 100 people are working in accounts department. That means this is also many side. Write it as M. We don't write N generally, we write M. So seeing M and N emphasizes the point that this is many to many relation. Each entity, each person, each employee over here may be, check my words, may be working for many departments. There can be some employee who works for only one department, fine. But there are employees who work for multiple departments, and a department can have multiple employees. What was the other notation I said? This is many to many, one notation. The other notation was not to show any numbers like M and N, but if you see an edge connecting a relation with an entity, and if you don't see any arrow, it means many. This is many because I have not shown an arrow. And here also I am not showing an arrow. That's it. This is many. So the both sides of the relation here are many to many. This is a many to many relation. Obviously, many to many relation can be understood from the requirement itself, isn't it? Of course, one to many can also be understood because it is written over there that a student can borrow exactly one book, something like that. So, by the way, this was many to many relation. Now, let's come to third type of relation. By the way, we have explored one to many, many to many, and now we are exploring one to one. I have just modified a few sentences here. Just check. Every student can borrow exactly one book at a time. Very strict library. Usually that's the fact. But then every student can borrow exactly one book at a time, and a book can be issued to exactly one student at a time. There is no change in this sentence. It cannot be changed in any library. A book can be issued only to one student at any point of time. So what do you identify over here? The student is an entity and a book is an entity. And the relation between these two entities is student borrows book. Of course, again I am not showing attributes like student ID, student name, book ID, book name and so on. But then what you identify over here is, if you ask any student, how many books have you borrowed? Student will definitely say one. I have borrowed one book. So one over here. And if you ask any book over here, some B1 book, you are with which student? That B1 will say, I am with student S1. Book can lie only with one student at any point of time. So this is one side. This is one to one. And according to our another notation, if we don't use these numbers, then book is one side, so arrow shown towards the book, and student is one side, so arrow shown towards the student. So that's one to one. Three types of relations we explored: one-to-one, many-to-many, and one-to-many. You know, still we have long way to go actually, but I hope that you have got some idea about the two words which is our subject for the day: entity, relation. ER, entity, relationship. That's what we have to take away today after this lecture. So, by the way, what do you have now? Oh, very interesting. You see, this point which I am explaining is very well neglected many times. No? Very well, conveniently neglected. But you have to repeatedly ask your customer about this, because if this topic which I am telling is neglected, then later on you will face such serious issues that you may have to restructure the entire thing from where you started. It's such a serious matter. This is such important thing that you have to grasp. You see, the point is participation in relationship. Very interesting. Participation in relationship. There are two types of participations: total participation and partial participation. What do you mean by that? Let's come to our example of one-to-many relation. So I'll go back. Just see, one-to-many. Okay, here. One-to-many relation. We are talking about participation. We have already spoken about cardinality. We have spoken about relationship. We are talking about participation, total or partial. Okay, here we go. A student can borrow many books. So N has been written at book side. Let's say there are 1,000 students in our institute. The student is actually set of 1,000 students. Many students are there in our institute. Check the requirement given. Student can borrow one or more books. It's not that student must borrow. You can't compel a student that you go to library and you should borrow a book. What that means is there might be a student S4 in our institute who currently, check my words, has not borrowed any book. Maybe not gone to library since when the admission was taken. So, but all these students, have borrowed some book, have borrowed. There is another student S6 who has not borrowed any book. What you understand over here, is that out of the set of students, all the students, it's not compulsory, it's not necessary that every student will participate in this relation. Which relation? Borrows relation. There might be a student who never cares about borrowing a book, or there might be 50 such students who never care about borrowing a book. What that means is this student set of students is not totally participating in the relation. When do you say that the entity like student is doing total participation? When all the elements of that particular entity, the set of students, will definitely borrow a book. But that's not true about a library, about a book. A realistic example, if you think of, that there might be some students who never borrow a book. We call this as partial participation. So we say student participates in the relationship, no doubt, but it partially participates. Then this line is kept as single line. So there is double line also. Yeah, there is double line. We will come to that. But whenever you see a single line, you say, okay, that means this is partial participation. It is not needed that all students must borrow a book. If there are, say, 1,000 students in our institute, then there might be some students who never participate in this relationship. They never borrow a book. Let's check this line on the book side. This is many side. Should this be partial or total? Let's question. You know, we have some 10,000 books in our library. 10,000 books. So this books represents the set of those books. Maybe B1, B2, B3, many books. B7, B8. And this B8 book, you know, I don't know why, but none of the students have ever borrowed this book. It is lying in the shelf since when it was bought in the library. It can happen. Then this B7 will not participate in the relationship. At least right now it is not participating. That means, is it important that all the books must be taken by some students at any point of time? In that case, library will be vacant. There won't be any books. Today you bring books, they are already issued to all the students. It never happens. That means at any point of time, you know, you may see some books not participating in the relation. So this is also partial, single line. Why book is partial in this particular relationship? Because it's not necessary that all the books might participate in this relationship. All the books need not be issued always to some student. So that's what here both sides are partial, isn't it? Now I am just changing one rule. I know you have guessed it. What change I am going to do? Just one change. If I say every student must borrow. Oh, what a compulsion. That means at the time you take the admission, you have been given a form and your signature has been taken that at any point of time you must keep borrowing a book. That means now there cannot be a student in our institute who doesn't go to the library and borrow a book. Every time the student must have a book which belongs to the library. That means all the students are participating. Definitely are participating. Then this is total participation. Whenever you see double line, it means that, you know, if there are say 1,000 students, then all 1,000 students are definitely borrowing a book. What do you say about book? You can't have such silly rules for books. You can't say every book must be given. Library should be vacant. At any point of time, all the books must be there with some students. Oh, hello. This cannot be done. So basically book will remain partial in our world at least. But that's the difference between total and partial. Let's go to one more example that we were learning. Okay, here we go. Total and partial. What do you say? My question. You know that employee works for department. And according to our requirement, every employee must work in exactly one department. So department is one side because employee works exactly for one department. But a department can have many employees. So this is not having arrow. This is many side. The only question left out here is, what about participation? Should there be a double line over here or single line? So my question is, the line attaching this employee and works for, this line should be double line or single line? If you say double line, you mean that it is total. If you say single line, it means partial. I am waiting for your answer on the chat. Should this line be double? If you say double, then it means it is total participation. If you say single, it means partial participation. Look at the requirement, look at the sentence, speak the sentence again and answer. Should it be single line or double line? Okay, it should be double line, right? Why? Every employee must work in exactly one department. At least I have not seen an employee who says, I don't have any department. I just go to the company and have my lunch box and then come back. See, if there are some 50 employees, they must work for a department. They should participate in this works for relation. This is total participation, isn't it? And that's evident from the sentence written over there. Let's ask department what this should be, single line or double line. Let's see. A department can contain 0 or more employees. Check the statement itself. That means there might be, let's say, 4 departments or let's say 5 departments. And this D5 is a department who currently does not have any employees. Yeah, this department is not having any employees. Maybe it is newly formed department. It can happen that some department does not participate in the relationship. That means this should be single. This is partial. Suppose I change the statement. The department can contain 1 or more employees, or rather must contain at least 1 employee. Otherwise, we don't keep that department. Empty department we don't keep. Department must contain 1 or more employees. In that sense, there cannot be a department like this who doesn't play a role in the participation or in the relationship. Then even this should be double line. But it was given that a department can contain 0 or more employees. So there can be a department who is not related to any employee. So that department is not playing a role in the relationship. That's total and partial. I guess you have followed it. You have known what do you mean by entity? Any place, object or thing is an entity. You have known what is the attribute. If there is an entity, that entity will have some properties, okay, like name, address, salary and so on. So that are attributes. You also known types of attributes. Yes, composite, multi-valued, key attribute and derived attributes. Then you have known that entities are related using relationship. You have known types of relation, one to many, many to many, one to one. And then you have also known that what is the participation of that in that relation. The entity participates fully or partially. You have known that also. Now where do you go? We have one more concept over here. Very interesting. Actually, I like this. I like this concept. You see, the only thing I promised which I did not fulfill in the beginning is that I said there are many types of attributes. Okay, I taught that. I said there are many types of relationships. I taught that. But I said there are types of entities also. I didn't teach. I'm talking about this entity like employee or department. There are types of entities. Let's now check the types of entities. Okay. Now you see there are 2 types of entities, strong entity and weak entity. Let's check. I'm talking about the place or a thing or a person, a noun I am talking about. There are 2 types, strong entity and weak entity. Now definition, is very easy. But we don't get satisfied with the definition, isn't it? But let's read out the definition. An entity which does not have key attribute is called weak entity. You remember student has a key attribute, student ID. Employee has a key attribute, employee ID. Right? But then there are some entities which do not have key attribute. If you are not able to think about what should be the key attribute, you are not getting for a particular entity, you are not able to understand what should be the key attribute, then you can say that this must be a weak entity. Here goes an example. Okay. By the way, if an entity has a key attribute, then it is a strong entity. Like employee has employee ID, that is a key attribute. So each employee has unique ID, a unique employee ID. So we can recognize an employee by its ID. So employee has a key attribute. So employee is a strong entity. Okay, so let's see an example. Every employee can have any number of dependents. Obviously, if I am an employee at GATE Academy, I will have some dependents. You know, my daughter, my wife, my mother, obviously. So one employee can have, just check my words, can have one or more dependents. There might be an employee who does not have any dependents. Strange, but that doesn't happen. But maybe that there is, say, a 19-year-old boy who has joined our organization and his parents are still working. So they are not dependent. But anyway, but employee can have any number of dependents, and every dependent will have relation with exactly one employee. Let's see what it means. But what do you understand from this, is that there are definitely two entities, employee and dependent. I hope you recognize that. Employee and dependent. And we say employee has dependent. First of all, you just see that I very quickly identified that the entities are basically employee and dependents. Now, what do you say about cardinality here? What should be the cardinality? An employee can have many dependents, one or more dependents. So this should be many side. So I will keep this as single line, line without an arrow. But if you take any dependent, take a person, some person, and ask that who are you? That person will say, I am father of so and so person. Only, come on. If you ask somebody, who are you? That say 6-year-old girl will say, I am daughter of so and so person. That means if you pick up one particular person here, that person will be related exactly to one employee. This is one side. Are you understanding? An employee can have 3 dependents. So this is many side. All right. And what about total and partial participation? I am still not coming to strong and weak entity. Wait a minute. We'll come to that point. But let's understand the problem in terms of ER model first of all, and then go to strong and weak entity. Okay. What about partial and total participation? You see, an employee has many dependents. But it may happen that the employee does not have any dependents. There might be some employee who does not have any dependents. I said few seconds back that an employee might be so young that all parents are working and elder brother is working. Then in fact, he doesn't have any dependents right now. Even he is not married yet. So there might be an employee who says, I don't have any dependents right now. So this side should be single line. This is partial. Immediately when you see a single line, you say, okay, there are some employees who don't have dependents. But can there be a dependent that you are registered here? Please try to understand. You can see many dependents over here. Can there be a dependent who does not have any employee related to? It can't happen. If you have stored someone here, definitely you are stored because that person is dependent on some employee over there. That should be total participation. I hope you are understanding. This should be double line. So which side is 1? Employee side is 1. Because dependent relates to only one employee. Any dependent relates only to one employee. Many side, dependent. Because one employee can have many dependents. Partial side employee, total side dependent. Now think about the attributes. Every employee will have unique employee ID. Key attribute, strong entity. So our company has decided to give unique number to every employee, EID. Then e-name, salary, and so on. Let's not spend time in drawing these attributes. But then what about dependent? You will say a dependent will definitely have name. Let's give D name, dependent name, of course. Then the relation. mother, son, daughter, what relationship that person has with this dependent. So relation, blood relation I am talking about. And then you would say, wait a minute, let me add a unique number to this, DID, dependent ID. So I have made a key attribute called dependent ID, and now this is also a strong entity. Nonsense, sorry. No. Actually, there is no harm in giving a number to each dependent. There is no harm. You can give, like we have given number to each employee. And people call employee number 101, come here, something like that. So you can give number to dependent also. Who has stopped you? But check my words, it is very insulting. It is very insulting that you give a dependent number to a dependent. Hello, there is somebody's father over there, and you give number like 101 is father of so and so person. That's not fair. You can't do that. I mean, see, this is magnificently superficial explanation I am doing, which might sound illogical initially or maybe sarcastic what I am talking about. But can you imagine our dependents, my son or maybe my mother, given a number over here? Well, we exist with numbers. Okay, we are working for a company. You can give us a number and call us by number, but you can't call my father or mother with a number. That's so unfair. You cannot have a unique number given to this. Well, still I say that there are n number of examples for which my explanation won't fit. But you know, I was just giving you an idea that what are the situations where you cannot think of giving a key attribute. You can't find a key attribute. You just erase the words like it is very insulting and all that. But I hope I have conveyed my point over here. It's not fair to give some number to the dependents, isn't it? After all, you are not going to call them by that number. How are you going to call the dependents? By their names. What we then do is these names, you know, are dashed. They are not regularly underlined like the key attributes, but they are only dashed. We say that they are identifying attributes of dependents. They are not key attributes. Why? Because two dependents may have same name. If my daughter's name is Radhika, then some other employee will also have a daughter whose name is Radhika. It can happen. So there can be two dependents with same name. But basically, you know, when these dependents are thought of, then they will be always thought of by their names. So this is an identifying attribute. That's why it has been drawn with dashed line. Now these things that we are learning, you know, will play a great role when we design relational model from this ER model. You see that each and every point that I mentioned over here, you know, plays a very important role when the next step of DBMS comes, that once you have created this ER model, looking at the customer's requirement, when you have modeled this on paper and shown the pictures, then ultimately the plan has to be prepared that the architect makes, and our plan will be making relational models. So I'll wait for just 5 to 7 seconds in case you want to ask something, some query. You may, or I will proceed to very interesting point, is that how to learn what is relational model. Look, I am not saying that our discussion on ER model is over. Not at all. But this model, if kept like this, is of no use. This is still on paper. We have to now transform this model into next step called relational model. Okay, fine. So getting the confirmation, here we go. The point that we are now going to learn is mapping ER diagram to relational model. First of all, what do you mean by relational model? You see, we started our lecture with ER model, entity relationship model. I hope you have gone through the tour properly of ER model. What is relational model? Is that relational model talks about tables. What happens is, if we have an ER model like this, employee works for department, and employee is having an attribute EID, employee ID, name and salary. Let's not waste our time, but 3 attributes. I could have shown more attributes, and EID is key attribute, and department is having DID, name of the department DName, and let's say department location is also there, DLoc. And you know these two entities are related using works for. And let's say one employee can work in, an employee can work exactly in one department, but a department can have any number of employees. The same picture which we had drawn a few slides back. Now this was the ER model, and what we do now is this ER model is simply converted into relational model. What happens is, this employee which is an entity, becomes a table. Table, by table I mean regular table containing rows and columns. And the table, so what we are doing is, we are transforming our diagram from rectangle to a table. This entity becomes a table, and the attributes become column names. So this table has rows and columns, and here we have attribute name and salary. You can easily see that the entity has got transformed into a table, and this table will be called as employee table. By the way, check that this table, the table which I have shown, is also called as relation. No, don't worry. Don't worry in this lecture. In this session, don't worry why is it called relation. Okay, but then when we come tomorrow, tomorrow also we have a session on relational model. Yes, the topic which I am discussing, relational model, we have actually the session on relational model tomorrow. But because we are learning ER model, I have entered this relational model, and the things which are discussed now won't be discussed tomorrow. So by the way, the table is also known as relation. No, not that relationship, not that one, the rhombus, no, not that one. The table is called relation. Relation is different from that relationship which we have drawn as rhombus. Okay, so what we have said, what happens in the relational model? Every entity, just check, every entity becomes a table, and every attribute of the entity becomes column of the table. That's what I have done, EID, name and salary. What about department? Listen, the mapping is going to be so easy, you know, that with such a comfort we are going to solve this, and we will say, oh, that's it, this is the relational model. But you see, all the efforts have been paid while constructing ER model. That's why this discussion becomes so easy. What is department? Entity. So this also becomes a table. This is department table, and then it will have columns as DID, DName and DLoc. Isn't it so? This is the department table. It will also have rows and columns. Just check that. So we have got two tables from the two entities. This is relational model, creating tables. Oh, hello, wait. What about this relationship? If we have shown it in our ER model, then it should come somewhere over here, isn't it? What do you do? Okay, wait a minute. But you see, you might wonder that what happens to the relation, because it's so easy. Employee, you know, EID, name and salary. Okay, this is employee table. This is easily department table. and department easily had DID, DNAME, DLOC. So 3 columns. What happens to that relation? Or can we just ignore that relation? How can you ignore? If you want to ignore, why did you show it? Now the point is like this. This is many-to-one relation. Many side is employee, one side is department. You see both these tables. Keep looking at both the tables. Employee has EID, name, salary. Department has DID, DNAME, DLOC. Very good. They know everything about themselves. Correct or not? Departments know about themselves. Employee knows about themselves. What salary and all that. Just check. If you ask some employee over here, which department you work? There is no information in this table kept at all that in which department is this employee working. Think as if that this is a separate file or separate muster or separate register. And when you open this register, what you may see is there is employee number 1 named as ABC. Let's think of arbitrary name ABC, and salary is, let's say, 500, whatever. But there is no track about which department is this person working in. What's the use of such a file or such an information? What you then do is, you add one more column here. Think over this. You add one more column here, DID. Oops, you will say that column is over there also, DID. Yes, I am talking about the same column. You just add that column over here. Let that column be over there also. Watch out that now employee table, wait, you will tell yourselves that yes, this is the correct way of tying both the tables. Although 2 tables are different. But look how we have tied them with a relation. That DID of department is there in the employee table. You will know what I am talking about, definitely. Just check an example now. Suppose we have 3 departments and we have numbered the departments as 100, 200, 300. Imagine just some numbers we have given, and department names are D1, D2, D3. Some names of the departments and locations are L1, L2, L3. So our company has 3 departments. Now imagine that employee number 1 works in department number 100. So we will store 100 here. Now you tell me, if somebody asks you that call employee number 1, what receptionist will do, or what that clerk will or concerned person will do? Will open that file and search employee number 1 and see which department he or she works. Department 100, okay. Quickly jump to the other file, search the 100 department, found at L1, go to that location and get that employee. Just check, keep checking. Employee number 2 may be named as DEF. This person also works in department 100, so store 100. You can now understand that a department like 100 can contain many employees. Who was inside? Tell me. Inside was employee side. Then make a rule here. If you are mapping, see, very simple rule. If you are mapping many to one or one to many, whatever relation, then key attribute of one side. Key attribute of one side should be added as a column in the table of many sides. Who was the key attribute of one side? DID. DID is just added as one more column or attribute on many sides. This is called foreign key. But wait, I won't talk about that right now. I will talk about foreign key tomorrow, when we are going to learn relational model in big detail. But these things won't be discovered tomorrow. As if we know how to map ER model into relational model, we will continue from wherever we left out today. Just come again, tell me, what do you do to convert one to many or many to one relation into relational model? convert every entity into table, and look at one side. Whoever is the key attribute of one side, you add that key attribute as a column on the many side table. So employee should have DID. Come on, let's see one more example here. Just check. Oh, what exactly is this? Okay, the same example. Just see, employee is many side and department is one side. So what exactly are we going to have? This is employee table. Employee is having EID. This is key attribute, and employee has e-name and salary. Is it? Or address? Okay, address. And now this employee will have DID also. In ER model, we did not show it, but when we map it in our relational model, then we say that these two tables, although different, are now tied with that common column DID. So you can see that a department, this is the department table, has DID and DName. I have not taken DLock over here. Now this is the key attribute over here. We say this DID is related to this key attribute. This attribute DID is actually called as foreign key, but I am just not going into that definition. I just want to teach mapping of these ER diagrams into the tables. So what's the rule? How is one to many or many to one transformed? Key attribute of one side should become an additional column of many side. Key attribute of one side, DID is the key attribute of one side, should become an additional column of many side. Now, yes, we have that example. Student borrows one or more book. What do you know? Student borrows a book, but a student can borrow n number of books, but a book can be only with one student. Correct? Now, map this. What will this student table be? Student table will contain roll number. Every student has unique roll number, then name, then address. Is that all? No, wait a minute. This is one to many relation. So you have to tie both these tables, although they are different. Anyway, let's talk about book. Every book has BID and book name. Now, what was the rule I said? How do you transform one to many into a relational model? I said that whatever is the key attribute of one side, remember, should be added as additional column of many side. So roll number is the key attribute of one side, so roll number should be added here. That's the foreign key which is coming from here. Just see very quickly, if these are our students, 1, 2, 3, 4, and some names, some addresses. And these are our books. Let's say B1, B2, B3, B4, these are our books. And some names of the books. B1 might be taken by roll number 1. It's so easy to understand that in the book table, you will be keeping the details of who has taken that book. Who has taken that book means which roll number has taken that book. And you know a book can be taken only by one student at any point of time. Isn't it so? So the key attribute of one side should become an additional column on many side. So maybe B2 is not taken by anyone right now. You remember partial and total. So this can be null. This book is not taken by anyone. But B3 is taken by roll number 1. We said that a student can take any number of books. So roll number 1 has taken 2 books, B1 and B3, and B4 has been taken by the second student. So that's how, so conveniently, we convert one to many or many to one relation into table. Repeat. What is the rule? if you are transforming one to many or many to one ER model into a relational model, then key attribute of one side should become an additional column of many side. We call it as foreign key. Tomorrow we will see what do you mean by foreign key. Okay. Now we are still understanding how to map ER diagram into relational model. You recall this ER model that we saw, say half an hour back. Employee works for department, and our employees working in this organization are miserable because an employee may work for many departments. So an employee may be asked to work for 6 departments maybe, and a department will definitely have many employees. So this was many to many, correct? And each employee is recognized by EID, e-name. Let's keep salary also, salary. So 3 attributes for employee, and department is recognized by DID. This is the key attribute, and dname. Okay, many to many we are talking about. We want to transform this into tables. How many tables will you get? You recall when we transformed one to many on the previous slide. When we transformed one to many or many to one, we had 2 entities and we had 2 tables. Note the tally over here. We have 2 entities and one to many relation. Then we have exactly 2 tables. So in the case of one to many or many to one, 2 entities will get translated into 2 tables. But in many to many, you are watching 2 entities. So definitely there will be a table called employee and there will be a table called department. No question about it. 2 tables, because each entity gets converted into a table. Now this employee will have EID, e-name and salary. This is the key attribute. And department will have DID and dname. This is the key attribute. Now listen carefully. We are talking about many to many relation. In many to many relation, we will have third table created. Although you are not looking at third entity here, there are only 2 entities related with a many to many relation, but there will be a third table created. The third table, I am drawing it here, the third table will contain exactly 2 attributes or 2 column names, and the column names will be EID and DID. Just check the rule properly. When you are translating many to many relation into tables, then both entities will become tables as usual, obviously, but the many to many relation itself will become a new table. And there will be exactly 2 columns in this example, of course, and the 2 columns will be the key attributes of both sides. That means EID will become one attribute, DID will become other attribute. Two entities make 2 tables. Relationship was many to many. When it is many to many, third table will be created. And what will be there in that table? Key attribute of one entity and key attribute of other entity. 2 columns will be there. Now, wait a minute. Now, what is the meaning of this? The meaning of this is that we may say that employee number 1, and there is a department 100. Employee number 2, and there is a department 200. Employee number 3, and there is a department 300. Now, what if this employee 1 works in all 3 departments? I told this is a very, harsh organization where an employee can work in many departments. What if this person 1 works in all the 3 departments? How are you going to record that? you will say employee number 1 works for 100. This department, employee number 1 works for 200. Employee number 1 works for 300. So what have you got? What have you understood is that combination of EID and DID should be unique. See, one can repeat, but EID plus DID both cannot repeat. This repetition is not allowed. For example, if I again store 100, this will be wrong. I hope you remember the definition of key attribute. Key attribute is something which cannot repeat, which should be unique. So what should be unique in this table? Combination of EID and DID should be unique. Just tell me, what if this person 2 works in only one department 200? Okay, so person 2 works in 200. But what if this person 3 works in 200 and 300? Then you will say person 3 works in 200, but person 3 works in 300. You can see that this combination of EID and DID is unique. So very simple rule of transforming many to many relation. If there are 2 entities, there will be 2 tables, and the relation which is many to many will be transformed into a new table, and the key attributes of both the tables will become the columns of that new table, and their combination must be unique. You cannot have 1 and 100 repeated again, because both together will form a key attribute. I hope you got that. And now the last fundamental I am telling, the last fundamental is about strong and weak entity set. Just see, this problem we had taken about strong and weak entity set, and we said that an employee has dependents. And we said dependent will have dependent name. This was dashed, and employee will have EID and ename, and maybe salary. Okay. Now I hope you are watching the video properly. Now I will disclose a few points. See, we have already known the discussion that we cannot have a key attribute like dependent ID or something like that. So we know this is weak entity, and weak entities are shown with double rectangle. Whenever you see a double rectangle, you know that this is a entity which does not have a key attribute of its own. Whereas this entity is shown in a single rectangle because this is a strong entity. Also, this relation is between a strong entity and a weak entity. You see both the entities. Then this relationship is also shown in the form of double rhombus. These are just conventions, so that when you see a double rhombus, immediately you understand that it is a relation between, or relationship between, strong to weak. Now, if this relation is given, or this ER model is given, how do you translate it into relational model? So definitely there will be a table called employee. Stick to the rules, employee and dependents. There will be 2 tables. Why? Come on, because there are 2 entities, and this employee will have EID, then ename and salary. 3 columns will be there because there are 3 attributes. Correct? And dependents will have 1 column, dname, name of the dependent. But we add 1 more column here, EID. The same concept I am explaining that I explained in one to many, just borrow the key attribute and put it in the dependent. It's so easy to understand. You just check. These are our employees, 1, 2, 3, 4. Let's say 4 employees. And these are the dependents. Let's say D1. Imagine some name over there. I am just writing some arbitrary name. D1, D2, D3, D4. What if you say 1 D1 like this? What do you understand? this person D1 is dependent on employee 1. That's what we want ultimately. We didn't want our dependents to be numbered. You remember that sarcastic and illogical explanation. But it works, isn't it? And this D2 is also dependent on 1. But this D3 is dependent on employee number 2. So we simply borrow the EID of the strong entity, that is the key attribute of the strong entity, and we put it as a column in dependents. This is again foreign key. This is a foreign key. Don't worry, we will see that when we resume our discussion. But rules are to be remembered. But logically, if you understand them, it becomes very easy. One to many, what do you do? One to many? Yes. In one to many, key attribute of one side becomes additional column of many side. Many to many? Yes. For the relation itself, for that rhombus itself, you create a new table. And key attribute of both sides become columns of that new table. Strong to weak? Yes. You just put the key attribute of strong side as additional column of weak entity. Okay. Now, just check this question which was asked in GATE. Very interesting. Just see, they have given these entities. You understand M is an entity, P is an entity. I'll write E here. And these are the entities, isn't it? M, P, and N. These are entities. You understand N is a weak entity because it is drawn in double rectangle. So obviously, this is a relation between strong to weak. So this is double rhombus. Okay, fine. And what about M1, M2, M3? These are attributes of this entity M. What about P1, P2? Attributes of P. N1, N2, attributes of N. Look how N1 has been dashed, not solid underline, dashed, like dependent name was. Okay. What they are asking, consider this ER diagram, the minimum number of tables need to represent all this. M, N, P, R1, R2. What are the minimum number of tables? Well, if you actually solve this using our rules, very simple. By the way, do you understand this is one side, this is many side? Because this is arrow. Now think of only this section. Take only two entities and their relation. Won't you say that there will be a table M and M will contain M1, M2, M3? Correct? M1, M2, M3 in M. And P, the other table, will contain P1, P2. This is the key attribute here. M1 is the key attribute. Anything else? Yes. You have to tie those tables. What was the rule? Key attribute of one side should be added as an additional column of many side. That means P1 should be a column over here. But how many tables you will need to transform this portion into relational model? 2. That's it. If it was many to many, you will require 3 tables. But here you will require 2 tables. Now let's talk about this portion. You can just check. This is strong to weak, and this is one side, that's many side. Now what did you understand in strong to weak? What do you do is, obviously we have already made table called P. We won't make it again, but we will make a table called N. And this table N will contain N1 and N2, 2 columns. One more. Just check. When you transform a strong to weak entity relation into a table, then the key attribute of strong entity should be added as a new column. So there should be P1 added in N. But how many tables do you require? 2 tables. And P was common anyway in the relation. So the correct answer is you need M, you need P, you need N. So the answer is you need 3 minimum tables to transform this ER diagram into relational model. And this was a linked question actually. You see, that's why I have written answer question 1 and 2. This was question number 1. the question 2, that was linked question actually. So you can answer this question only if you know answer of the previous question. That's what the meaning of linked is. Which of the following is the correct attribute set for one of the tables of the answers that you found in the previous question? So they are asking that, okay, you got the tables, it seems that you got the tables, but then what is the correct attribute set of one of the tables? If you see, we have got 3 tables and M contains M1, M2, M3 and P1. M is the table which contains M1, M2, M3, P1. That means this is the correct attribute set. Okay, let's see what are the other tables we got. We got P, which contains only P1, P2. P contains only P1, P2, and we got N, which contains P1, N1, N2. We got N, which contains P1, N1, N2. Correct? These are the 3 tables we got. And check the other options. Is there any table which contains M1, P1, N1, N2? No, you just check. The correct attribute set is A. But this is possible only if you have transformed. In the previous question, you have transformed that entire diagram into the tables. Once you found the tables, the attribute set can be found. So this was the tour of ER diagram and relational model. I hope you have found the session very interesting. Just get back to us with more queries and doubts if you have about this session, and do join us tomorrow at same time 8 p.m. on GATEvantage series, where we will explore more things about relational model. Thank you very much.